Why don't we go down and introduce yourself and the company you work for, then we'll jump right in.
Hi, my name is Vince Fong. I'm the CEO of Highrise. We're the compute platform built on top of Hut 8, which is a digital infrastructure company. We manage over 1.5 gigawatts of power, so we're fully verticalized from energy origination to colo to compute. Excited to be here today.
Hi, my name is Felix Ejeckam. I'm the founder and CEO of Akash Systems. We make diamond-cooled servers. These are servers, most capital efficient and energy efficient servers in the world. They're used for data centers, AI, and cloud service providers.
Hi, my name is Alexis. I'm the CMO and President of the Americas for Axelera AI. We started at the other end of the spectrum. We started with 4 watts and the highest performance per watt in the market for inference specifically. We're now taking that same architecture and scaling it into data centers because we fundamentally don't believe you need all of that power to get that performance.
Hi everybody, my name is Erwan. I'm the Chief Product Officer at Crusoe, which is a neo cloud. We do everything from electrons to tokens. So we source and produce energy, we build data centers, we offer infrastructure as a service, and manage inference.
All right, the big gigawatt scale, Crusoe, we had a comment earlier in one of the panels, so we'll get to that in a second. Diamond cooled, got my attention there. Explain diamond cooled. Like diamonds?
Absolutely.
So this is real on Instagram.
Yeah, so these are lab-grown diamonds. We grow this in the lab. This is a very typical piece of diamond substrate. These are lab-grown, we don't mine these. And the reason why this is interesting is that it is the most thermally conductive material in nature, in the world. We take this and we place it right on the GPU. By so doing, we reduce the temperature of operation by about 10 to 15 degrees Celsius. That causes the inference time to speed up, and it also reduces the cost of cooling the data center. Net, this returns about $1 million in cash per server to the owner of the GPU, of the server. So that's what we do. It gives returns back to the operator, and it's by reducing the cooling cost of the GPU.
That's very innovative. Let's talk about the Neo Cloud layer up here, Crusoe. The future of cloud computing now with GPUs is about large-scale data factories, AI factories. You guys are building the most modern, largest capacity power out there. This is the trend on the big factories, but there'll be small factories. What's your strategy as you engineer these things? You run engineering. What is going on with these AI factories?
Yeah, actually it's a good segue to the previous panel on inference, right? I mean, we build gigawatt scale factories, and on inference, we anticipate that you'll want to do inference at the edge at some point. So we have a modular data center. Think of that as half a megawatt box. You can put 20 of them together and build a 10 megawatt data center, AI purpose built, and you can put it where you need to. So you can put it close to the end user to improve inference. You can also do it in the right place for sovereignty reasons. So yeah, I think we're going to see gigawatt factories and very modular edge type smaller factories.
Yep, I got that one right. Alexis, you could have also could have been on both panels. You could have been on the inference panel and this one, but you're making the chips. Talk about your unique approach. And you have history. You've seen this movie before, Intel.
I have. So I've been in semiconductors for 21 years and focused on AI ML for about 10 of that. So our approach is digital and memory compute. And what that means is that we actually put the memory right next to where the computation happens, which is why I can be so performant in such a low power envelope. The intention behind that is if you can solve for an area that has constraints, and you can put compute where those constraints live, then you can take that architecture and scale up. Never in the history of compute that I am aware of has somebody started in a, I'll call it big compute, and been able to scale that architecture down without fundamentally starting over, either on the software side or on the architecture itself. So we started low and are scaling up because, to your point, We believe, and we fully agree with the data that says 80% of compute is going to be inference over time, right? And why is that? Well, because inference is really just about speeding up your workload, whatever that workload is, whether it's your database, it's your ERP, it's your, your CRM. It's really a matter of how are you bringing more productivity into that environment. And we believe that the further you can push that towards where that data is created, the more people will do that. Right, if you think about your phone, phones didn't exist 20 years ago. Well, what's happened? We've just continued to push compute that was in a data center now into your hands. Same idea here as we think about inference and how you can do inference at big scale, or you can do inference very locally.
I got to ask the question that's on everyone's mind, which is why is NeoCloud so successful when you have all these big hyperscalers like AWS, Azure, Google Cloud? Aren't they good enough? Why AI factories? Why NeoCloud? What gives? How would you answer that?
I think at the end of the day, you're going to see more and more power and utility company instead of just software company and a compute layer. Fundamentally, everything comes with power, and we're seeing a shortage. Ultimately, you can solve the chip availability issue, but power takes time. There's regulation, there's a supply chain that goes into it. So our bet is very simple. You can coexist what the hyperscalers need, but at the same time being able to set up from the stack, from energy to colocation to compute, which is what our Hut 8 Highrise approach is, in being able to sit on both sides of the aisle, similar to Crusoe as well. And we're very excited about this new category of the infrastructure and energy first approach.
But don't they have the piece parts? I mean, to me, it seems like the NeoClouds are moving faster and engineering things differently because of the demand. I mean, this massive AI infrastructure demand, is it faster, smarter, entrepreneurial, or is it technically better, or both?
I mean, first of all, when you have the luxury of doing this and this only, you just look at the problem deeper. I mean, the portfolio of AI services in cloud is much smaller than a broad general enterprise portfolio. So we can build a data center that can take 120 kilowatt per rack density and everything from sourcing energy to the software is for this. And we do only these workloads. I think it's a privilege to be able to focus.
What I'd love to ask you guys is how do you see intelligence factoring in? Because you now have distributed opportunities to decentralize all these big factories so one doesn't get bombed, goes down. We saw that 2 weeks ago. What is the technical and business drivers for these AI factory architecture and the distributed nature of it?
My perspective on it, right, is the driver is really simple. It's really a matter of how are you making money or saving money, right? And in this scenario, you could be making money or saving money because you've given yourself redundancy that you would not have otherwise if you localized or chose a centralized location. I think what happened, last week is really proof that people want a different type of setup, right? And there's a lot of conversations. My company's Dutch, so we're European. There's a lot of conversations in Europe right now around EU sovereignty and how are they taking advantage, or how are they creating an environment where you can have your own data centers, your own AI, your own factories that can do things like protect your national language, right? A lot of these foundational models are all trained on the internet that's predominantly English. How do you actually keep those types of things moving forward and in that environment? So I think a lot of what we're seeing from a technology perspective is it's really trying to serve that underlying need of, I want to protect who we are as a nationality, or I want to protect who we are as citizens in terms of having our own destiny.
I think the Amazon Web Services Middle East data center outage and being bombed is a case for distributed data centers. The resilience, they were down for 3 days. Well, I don't know the exact, might have been more, but that makes the case for intelligent infrastructure. Any comments on what that looks like?
I think we saw the beginnings of that during COVID. I think that was the first signal to us as developers to lean into that distribution that you're talking about. Otherwise, you're going to be very, very vulnerable to what we just saw a couple of weeks ago. So absolutely.
Well, and it puts more pressure on the software layers, right? Because to be able to drive your compute at the edge, you need a very different architecture than what you're going to want in a data center or what you're going to want in a gigafactory. That software has to make it fairly seamless, right? Because the last thing developers want to do is operate in multiple environments, maintain multiple code stacks, code distros. So that software layer, that universal solution that helps move your data, move your algorithms securely, but also quickly, I think becomes even more important than just the architecture underneath.
And Jensen puts out an NVIDIA, always in charge, but he previewed his 5-layer cake. Energy at the bottom, the different layers. We were earlier in our Palo Alto studios with theCUBE, and someone pointed out that there's no data layer. So talk about the role of energy and data, because data feeds the factory. They're going to be pumping so hot, get the diamond cooling in there, Felix's company, but you got a lot of data coming in and you got the energy. That seems to be bounding function. Thoughts on this?
Yeah, there are two aspects to it. One, when we store data for training or anything around an inference, you really want to look at the storage cost in terms of kilowatt. It's actually more important than dollars in a way, because you don't want to spend more than you need to on storing that data. You want to direct your power to the compute. The other aspect is to use data yourself to be smarter at using the energy in the data center. So applying AI to your own craft as a data center operator to get better at extracting everything you can from every kilowatt.
Kilowatts is the new dollars. We put some cryptocurrency around that and maybe get it market.
Well,
Probably working on that.
We were born in cryptocurrency. Now, Bitcoin mining is very tolerant, right? It works if you lose access to the internet or you lose compute. We actually divested that business to focus 100% on AI. It's a slightly more difficult product.
Different token conversation. Thoughts on data?
Well, maybe just to give you a data point, in a prior life, I had a major customer tell me that every single watt that got added to their data center cost them $1 million globally, right? Because that was just the amount of power that was getting consumed. So to me, it actually is a bigger argument for distributed compute because, to your point, if I can process and analyze the data when it's being created, I know what matters and what doesn't, which means I don't have to send everything back to then store it and analyze it later. So you can start to filter out the noise, basically, right? Signal versus noise ratio goes down.
Add to your comments about energy, your question there. So our view of the world is that energy is a limited resource. When we go to a customer, we say to the customer, for whatever your budget is, don't expand it, don't change it. We will come in with our technology and reduce your PUE to 1.1. So if you can't afford liquid, that's fine. With Diamond, we can get you to 1.1 without the huge infrastructure investment. If you do have liquid, that's even better. We'll get you further still to a reduced cost of use. Your total cost of ownership will be far better than if you were to go with another type of technology. So that's our view of the world, is not to expand the energy spend, but to freeze frame it with our clients and have them try something new where they can be capital efficient.
Yeah, last point to add. I think at the end of the day, there's a lot of conversation on power, but 1 megawatt here is not equal to the same megawatt there. It comes down to quality as well in terms of the end scalability. What we've been mainly focusing on is single large offtake in being able to scale from hundreds of megawatts to gigawatts. So the planning in terms of the use case from a data center design perspective, the traditional way of approaching it is fundamentally changed, which go tap back into start with the compute use case, then backtracking into the energy infrastructure so that you could design this and optimize this for the specific use case, not just now, but also for their future scaling.
Well, you guys are all doing some great stuff. I guess my last question is the same question I did to the inference panel. From a year from now, what will change? Will the pricing change? Will the engineering change? Because you're talking about engineering AI factories. This is just throw some racks out there and manage the power, because power is money. Data is the raw materials for these AI factories. What's the big change 1 year from now? Come back to GTC, we're here.
I think in a year from now, if you did not factor energy in your strategy, you have a huge supply problem. I mean, we can see it, with silicon data. You look at the H100 index, it's pretty clearly saying that there is overwhelming demand. So in a year from now, I think any reasonable AI strategy has to start with energy, because that's the ultimate bottleneck.
I agree with you, and I would add that I think we're going to see a very different software landscape. What I mean by that is there's a lot of companies that are looking at taking these big foundational models and squeezing them in a way that you can fit them on a smaller energy footprint, smaller compute footprint, and I think that'll start to then create another cycle of innovation.
I would say that a year from now, we would be looking at demand for physical AI, the things that we do, would be probably about 5x greater than what it is today. In other words, we are still at 1995, 1996 internet, if you want to put it in that framework.
I think a year from now, echoing this point, is that energy and compute is basically going to become more and more in one form, just purely because of how it's structured on needing a 15-year take on it, and compute contracts only 5-year. So if you're not sitting on both sides of the aisle to have the flexibility to go from financing it to sourcing it to providing it, I think it's going to get increasingly difficult given size is just going from 10 megawatts to hundreds of megawatts to gigawatts in conversation. So I think there'll be more consolidation happening in the market and the power players moving up the stack.
Well, you guys do great work. We really appreciate the work that you do, because I think next year the demand will be even higher. I think it's at the beginning of a build out, and I want to thank you on behalf of SiliconANGLE and theCUBE and the NYSE Wire community. Thank you so much. Give a round of applause for the panel. All right, enjoy the rest of the